Hello, and welcome to AI-Driven Labs. The revolution has begun. I'm Mark Morman, and for the next several minutes, I'll take you through the use of artificial intelligence in laboratories, what you can expect, how you could prepare for it, things that you can do to be more successful with the use of AI in your laboratories. I spend a lot of my time talking to people about, well, what would this lab of the future look like? And one of the things that we're pretty aware of is that technology all around us in our personal lives is changing, and it's changing the way we do things. And certainly the use of artificial intelligence in today's world is quite common. We see it in things like personal assistants in Siri and Alexa. We see it in our thermostats. We see it in our phones that track our steps, and watches that track our steps and our heart rates and things like that, and predict what we're doing. We see it in self-driving automobiles that's becoming closer and closer to reality. And so we know that artificial intelligence has value. We've seen it in our daily lives. And of course, that's going to project itself into our business lives if it hasn't already. And in fact, I'm sure for most of you, there's already use cases you're well aware of where artificial intelligence is making an impact in your work life. But I think it's reasonable to expect that that's only going to grow. And there's a couple of reasons for that. One is the investment into artificial intelligence right now is at an all-time high. So it's somewhat of a self-fulfilling prophecy. Just like anything else where you invest so much in it, there's a certain natural outcome of that you will find benefits from it. Will we achieve everything we want to do? I don't know. I don't know that. But I do know that there's lots still to achieve, and we'll continue to achieve it. In the laboratory, what that means is, quite frankly, that we need digital assets. Obviously, everyone knows this, that if you don't have the digital assets, you don't have any ability to do learning on them or to do activity from them. And so digitizing the lab is the first step. That means, getting a good LIMS system to digitize your processes, using electronic notebooks to get off pen and paper, getting digital equipment that communicates or captures the data and probably communicates through Wi-Fi with each other, and obviously with some controlling system. And so the collection of those digital assets, that's a critical first step. And that becomes that starts to be the basis of what we would call a digital twin. And that's really a representation of your lab in a computer, or in a digital effect. And that gives you lots of functionality. Obviously, for monitoring and maintaining the lab, that's a great asset to have. But also for doing things like experimentation on the lab, and running experiments that don't affect your productivity and outcome, and running thousands or hundreds of thousands of them in minutes or hours, and understanding what impacts they would have on the lab and what outcomes they would have. Digital twins are capable of doing these kinds of things. And that digital enabled lab is sort of the state we're in today. People should be digitally enabled. They should get rid of analog instruments, or at least find ways to digitize information from analog instruments, and get interconnected. Start to use wearables, certainly glasses, and carry tablets and those kinds of things. And so that digitally enabled lab is today. The automated lab is sort of the cutting edge. We're starting to see some of it in different industries and different places, but where you automate functionalities. I heard a story, or read a paper actually, on colonoscopies where they used AI to look at the digital outcome of a colonoscopy against the physicians, who were accurate about 78 or some percent of the time. The computers were like 86% of the time. So the computers had a better way to look at the colonoscopy, which means you could automate the colonoscopy. Obviously, you could have a set of computers. You would run all your colonoscopies from it, and you could see how fast and how much throughput you would be able to get by leveraging that kind of technology. And so we're starting to see this automation, this ability to leverage the capabilities of AI and compute power to automate things. And then in the future, there's this idea of autonomous, where the lab would then also not just automate functions, but then make decisions on them and drive itself and become more self I don't want to say aware, that's not at all what I'm talking about, but become self-controlled, self-managed, self-maintained. And that's the future that we see for laboratories. This all comes from technology disruption, and of course we've been through a large cycle of technology disruption that's brought about a pretty modern, pretty incredible world that we live in today. And that comes obviously at the beginning from connectivity. When we connected everything through internet technologies, and then of course the processing power of computers continues to grow, almost exponentially, to quote Moore's law. And we've created this highly connected, which means we capture a lot of data, and this amazing compute power that continues to grow and evolve. And that gives us opportunities to do disruptive things, run new modeling techniques, collect data, and innovate in new ways. You can see this in things like, the creation of the mobile devices, the creation of the internet, as I mentioned before, wearable technologies. So there's these disruptive innovations. And what happens is those disruptive innovations get amplified when they're put together. And, like what would Uber be without mobile phones and the internet and auto payment systems, digital payment systems? Those three disruptive innovations created a whole business model for Uber. And of course, there's many other examples of that. So those new business models then accelerate change. And we find that that acceleration of change does two things. One, it makes us all better, because we have to keep up with the Joneses, or we have to keep up with our competition, or whoever it is that's in our space. And so, but we learn from them as well. So there's a certain competition, but there's also a certain cooperation where we learn from each other and we grow. And that's what's really, we should keep our eyes on this idea of disruptive technologies and the building blocks of those disrupting technologies that drive new business models and ultimately accelerate our changes. And this has a big impact on business. So this particular graph that I'm showing here comes from McKinsey, and it basically lays out the green are people who don't adopt AI technologies at all, and the people in the blue do some experimentation and play around. Let's say they play around with AI. But the people in the orange are committed to AI. They're proactive. They've adopted it. They're using AI. And the scale is actually profit margins. So what we see is that people who, corporations, this is really corporations who don't use AI or play around with it, just basically are experimenters, have a similar outcome with regard to profit margins. In fact, you don't see much separation. In some areas you see some separation, but in other areas you see very little separation. In some cases you see lower profit margins for people who play around with AI. However, the orange dots are all higher, and in fact show quite a bit of separation. And what this tells us is, quite frankly, and your goal may not be higher profit margins, I understand that it may be, but it also may be things like better drugs, better outcomes, better health. I understand that. But what we can ascertain here, or start to believe here, is that if we believe in AI, then we have to commit to it. We have to have a proactive strategy. We have to have a plan. And so you don't play around with AI and think you're going to achieve great goals. You have to be committed to it. You have to have a plan. You have to be proactive about it. And I think that's a critical thought that not all of us have gotten. And if you think about that, that brings us to this next thing. I've seen statements where 85% of AI projects fail, or maybe don't fail, but they fail to deliver the value or never get implemented in production. And so why is that? Well, one of these, I think, goes back to that last slide. People who research or experiment with AI tend to fail more often than people who develop AI. And there's a mentality there, the research over the development. And one is a proactive, outcome-based. It has a much more outcome-based philosophy, whereas the first one is more learning and seeing. And you can understand why those two would be different. So one thing you're going to have to do if you want to be good at AI is you're going to have to commit to it. Now that does bring up the availability and cost of resources, as well as the knowledge of what to do. and to in a different way, disparate and changing technologies. So what you have is you have high cost of people that know how to do this, and availability. There's not as many of them, although it's a growing list. You yourself don't really know what to do. You're probably not, your organization's probably not AI professionals. That's not what you do as a business. And the technologies are changing daily. I mean, there's thousands of technologies out there. So how do you navigate that? So those three buckets also cause lots of problems in project value delivery. And there's an easy way around. It's not easy, but there's a way around this, and that is basically to partner. Find a partner who is an AI expert and help them with, of course, providing the resources and the knowledge and direction of what to do, and to manage the disparate changing technologies. Now, they don't have to be the same partner, but they could be. Obviously, I speak on behalf of LabVantage, and our LabVantage Analytics group does exactly this. Those three bullets is what we provide. We provide the resources and the knowledge of what to do and the platform on which to do it. And then that brings us to the last one, which may also be the most important depending on what kind of AI you're using, but this is how the current business process disruption. So if you build a great model, but you don't have a way to put it into your process flow, then you don't have the outcomes that you expected. And so there's management companies that help with that. And of course, our company can help with that as well. But this is something that you have to think about and be prepared for, is if we succeed in this, what disruption will it have and how will we manage through that? So let's talk a little bit about the ability to model. It's certainly, since maybe even 2012 with the, the introduction of, deep learning techniques that have changed modeling since then, we've gotten in a whole new space when it comes to modeling. And DeepMinds, which is a model design company, part of the ABC group or Google group, have been working on the Alpha project. You may have heard of AlphaGo. You may have heard of AlphaFold as well, but AlphaGo is the AI that plays Go and is basically beating everybody. And there's a great documentary on it out there on one of the streaming networks. Can't remember which, but AlphaFold was the same modeling technique applied to protein structures, and particularly how to predict protein structures and protein folding and those kinds of things. And so if you look at this model, it's incredible, and I love this graph. The graph shows what the experimental results, like the results of testing, real testing as we like to call it. That's the green in these graphs. And then the blue is the computational prediction. That's the AI. And look how closely the blue mimics the green, and that's called model fit or accuracy or recall and all those things. But the idea is it really matches well. Now, this is interesting to us in the pharmaceutical business, but it's also interesting to other industries, and it's interesting to us beyond the proteins. This type of modeling can be applied to many different things. It can be applied to predictive maintenance. It can be applied to optimization. It can be applied to categorization. And these are things we could use for things like quality failures and of course, predicting failures to equipment and those kinds of things that may disrupt an ongoing experiment. And so this idea or this vision here just shows how well these modeling techniques work, and what that means is they can now be used in vigor in our business processes, and we can actually rely on them. And so how does that happen? Well, really quickly, there's three little boxes on the screen, or three images on the screen. Let's say they represent real data, and forget what data it is. That's kind of irrelevant to this conversation, but they're real data, and in each one of them, there's a reddish color to a greenish color, green being good, red being bad, and then there's some yellow that's in between. Now, in the old days, prediction techniques, things like linear regressions, quadratic equations, logarithmic events, you would run those, and they would basically build a curve, and it was kind of a linear curve or a non-linear curve, but it was kind of a single curve. And what you would do is you would would separate these groups, or you would predict on these groups and have a prediction line. And as you can see in the middle graph image that we've done that, and it's done quite well. We've culled out a lot of the green. There's still some yellow, some orange, and maybe a red or two in there. But we've done a good job of finding things. However, we missed a lot of green. There's a lot of green that's been missed in that single curve. Now, what this disruptive technologies of the higher compute powers have done is they've allowed us to take this big image and do the big curve and break it down into thousands of smaller subsections of data and do those curves on each one of those, allowing us to be more predictive and more aggressive about what is green and what is red and how to manage that. And so our false positives may go up, or our false negatives, and false positives, false negatives, it just means the ones that the prediction missed, may go up or down, but you can manage that in these new models and you can get a much higher quality or a much higher outcome. And that's really how this works, quite frankly. And there's a transformation curve that you need to be aware of and you need to be on at some point in time. And it's not that you're in one of these categories and in one of these categories only. It means that you're more aligned to one of these categories today, and you should be thinking about how to get to the next category. And the first one is monitoring. I call that the rear view mirror. That's where we look back. We have good digital assets, and we can see what's happened in the past. And that's interesting. Obviously, we can report on that. We can make some business decisions based on that. We can have a better understanding of our lab. So that's a good place to be. But obviously, you don't want to stay there. It's important then to take that monitoring and turn it into control. Then what can I embed in my products that would make them better? How can I control? How can I steer the car some and change outcomes? And that's the control. That's where you start to do prediction, forecasting, those kinds of things. And you start to control things with your digital assets. When you get to optimization, now you're not just controlling them, you're picking the best route. So now it's we've moved from the steering wheel to now we're using Google Maps, or we're using maps, and we're driving the car with some real knowledge of the best route to go down. And now we have clarity, not just about how to steer the car upon a curve, but how to drive the car to a destination. And then with autonomy, we get to the place, and not to labor this car metaphor too much, but with autonomy we get to the place where the car drives itself and it begins to remediate things and fix things and drive along and make decisions in real time and based on a wide range of data. And that's sort of the maturity curve, and as you work through that maturity curve, it's important that you understand it and that you find ways, and there's ways that we help customers move, where people can move from one level to the next. Obviously, there's a lot of value to this for laboratories. If we could improve the diagnostics, then of course we'd have we'd have better outcomes, better laboratory workflows. We could improve the decisions we make. Obviously, there's some cost reduction with higher efficiencies, and with automation and automation, you just find faster, cheaper, more efficient, more effective. You basically get not everything, but you get much more output from the lab than you would have today. And so, we kind of use this Industry 4.0, but to get to here, and we've already talked about this, so I won't belabor the point, but I'm going to make one statement on this slide, and then I'm going to move on, and that is that when we talk about digital assets, there's this desire then to create another data asset, like a data lake or a data warehouse or data mart or whatever, but that's not really the way to handle this. And so if you look at this, you do have to integrate all the systems that impact your lab. We understand that. You want a 360 view of the lab, if you will, or the business even. Forget just the lab. You want it to go beyond the lab into the business and understand how new products will affect marketing and how marketing will affect new products. But the goal here is to get a fabric of information that you can use. And so when we talk about this digital, we need to think not about a new data warehouse, but about a new data philosophy that allows us to weave the data together into a fabric that is consistent and ready for digital use. And that brings us to the steps. Obviously, you begin with a use case. Those use cases are critical. If you don't find good use cases, you're going to have failure from the start. Once you find a use case, you can start to look at the data ecosystem that's needed to meet that use case. Once you understand the data and the use case, you can start to look at tools and techniques. How would we capture this data? How would we manage this data? What kind of models will we run? What kind of tools will we need for that? Once you've done that, you can see how that would impact the workflow. What kind of integration into the business would that be? Where would I integrate, and how would I get the AI into the workforce? And then obviously at the end is what organizational changes or cultural changes would have to happen. Our organization runs workshops to help you through this lens. I call it the lens as you look through like a telescope. We run workshops to help you through this, but you have to think in this term. What's the business use case? What's the data necessary? What kind of tools and techniques will I use? How will the workflow impact my processes currently today? And then what kind of cultural organization changes will be required to make the most of that outcome? And so on top of that, these are just some things you can, obviously the data lake is that data fabric, forget the word, but that's the data fabric that you build. On top of that, you have your modeling and statistics. You're probably doing that with things like JUMP and SAS and R today, but you could integrate that into one holistic platform. You start to use natural language processing to look at PDFs and documents like that, to look at tests and processes that you've done that we can now compute down to outcomes. You use computer vision, as I've already mentioned, on digital assets, maybe looking at things and getting a better vision of things. That brings about process optimization. Obviously, your quality and stability becomes a critical asset here, and you can start to be very predictive and very, very advanced in how you manage your quality and stability. And ultimately, your laboratory performance will go up. I'd like to thank you for the time that we spent here. If there's any questions, feel free to reach out to me. I'd love to hear them. I'd love to hear any of your thoughts, good or bad. It's always interesting to learn. So thank you, and all the best.